Today, we're going to learn how to do a related samples t-test. So, a college baseball coach wanted to experiment on 8 of his fastest pitchers. He wanted to see how fast his pitchers threw before they had rested after a long, exhausting day of practice, and the next morning after they had been rested and refreshed. While his pitchers threw incredibly fast both times, the coach noticed a difference in the pitches before his players had rested and after they had rested. So, for the unrested pitch, pitcher 1 threw 93 miles per hour, pitcher 2 threw 90, 3 through 95, 4 through 92, 5 through 95, 6 through 91, 7 through 92, and 8 through 93. For the rested pitch, pitcher 1 through 98, 2 through 94, 3 through 96, 4 through 91, 5 through 97, 6 through 97, 7 through 95, 8 through 97. For the differences, pitcher 1 had 5, 2 had 4, 3 had 1, 4 had -1, 5 had 2, 6 had 6, 7 had 3, and 8 had 4. For our hypotheses, we're going to say, for our null hypothesis, that the difference in two population means equals 0. And for our alternative hypothesis, the difference in the two population means does not equal 0. We're using a two-tailed test with an alpha level of 0.05. To find our critical value, first we have to find the degrees of freedom, or n-1. Our n is 8, so our degrees of freedom would be 8 minus 1, or 7. So we're going to consult the t-distribution table in the back of the book and look for a two-tailed test with an alpha level of 0.05 for degrees of freedom equals 7, which gives us 2.365. We're going to be using 3 formulas. So the repeated measure t-statistic, which is t equals the difference in the two sample means minus the difference in the two population means over the estimated standard error. But first we'll have to find variance for d, or the difference in the scores. So sample variance equals sum of the scores over sum of the squares over n-1. And then we find estimated standard error, which is the square root of the sample variance over n. So first we have to find the mean and the sum of the squares. So we take the scores and we add them up, so we get 24. So we take 24 and divide by n, or 8, which gives us our mean, which is 3. Then we do the scores minus the mean. So that gives us 2, 1, -2, -4, -1, 3, 0, and 1. Then we add them all up, and if they're correct, they equal 0, which means we have to square the sum here. So we get 4, 1, 4, 16, 1, 9, 0, and 1. So we add all these up, and it gives us the sum of the squares, which is 36. So now we have to work the problem. First we're going to do sample variance, which is sum of the squares over n-1. So our sum of the squares was 36, and our n-1 is 7, which gives us 5.14. Next we have to find the estimated standard error, which is the square root of the sample variance over n. So we do square root of 5.14 over 8, which simplified gives us 0.6425, and we square root that, which gives us 0.802. So finally we do the related samples t-statistic test. So that's the difference in the two sample means minus the difference in the two population means over the estimated standard error. So if you recall, our mean was 3, and we have 0 for the difference in the two population means because we said that in our null hypothesis that the difference in the two population means equals 0. So t equals 3 minus 0 over 0.802, which gives us 3.74. So we go to our curve, and remember our critical values are 2.365. So we have them here, here, or we have them here and here, and then 0 here. And our t is 3.74, which puts us right here. So for our result, we reject the null hypothesis. The obtained t-value falls in the extremes of the critical region, so therefore we reject the null hypothesis. There is evidence that resting before pitching causes a significant difference in the speed of the pitch. So that has been how to do a related sample t-test.